Our solar system is a vast and wondrous place. It's filled with planets, moons, asteroids, and comets. One such story revolves around Jupiter, the largest planet in our solar system. It's a gas giant with a swirling atmosphere and a faint ring system. But Jupiter's story isn't just about the planet itself. It's also about its moons. Jupiter has dozens of moons, each more fascinating than the last. Among these moons is Callisto, a world of mystery and intrigue. Callisto is a place of ancient craters and icy plains. It's a silent sentinel that has witnessed billions of years of cosmic history. This story is about the formation of our solar system and the possibilities that lie ahead as we continue to explore our cosmic neighborhood. Jupiter's moons are a fascinating area of study for astronomers. Among them, the four largest, Io, Europa, Ganymede, and Callisto, stand out. These are the Galilean moons, named after their discoverer, Galileo Galilei. In 1610, Galileo pointed his rudimentary telescope towards Jupiter. He observed these 4 points of light moving around the giant planet. This discovery revolutionized our understanding of the solar system. Callisto, the outermost of the Galilean moons, stands apart from its siblings. Its surface is ancient and heavily cratered. This ancient surface provides a window into the early solar system. It holds clues about the conditions that existed when planets and moons were forming. Unlike some of its neighboring moons, Callisto lacks significant geological activity. Its surface is a frozen record of the past. The craters on Callisto's surface vary in size and age. Callisto's surface is primarily composed of rock and ice, a common theme among Jupiter's moons. This ancient cratered world holds secrets waiting to be unlocked, secrets that could shed light on the formation of our solar system and the conditions that led to the emergence of life. Callisto stands as a silent sentinel in the vast expanse of our solar system. Its surface is a testament to its long and tumultuous history. Unlike some of its Jovian siblings, Callisto is not geologically active. This lack of activity has preserved its ancient surface in remarkable detail. Craters, large and small, pockmark its icy plains, each one a record of a collision with an asteroid or comet. These cosmic scars tell a story of a time when the solar system was young and chaotic. Callisto, with its weak gravity, bore the brunt of these impacts. Each impact left its mark on the moon's surface, creating the craters we see today. By studying the size, distribution, and composition of these craters, scientists can learn about the objects that have collided with Callisto over time. Callisto's ancient surface offers a unique window into the past. The discovery of Callisto in 1610 was a pivotal moment in the history of astronomy. Galileo Galilei, an Italian astronomer, pointed his newly improved telescope towards Jupiter. He noticed 4 faint points of light near the giant planet. Over several nights, Galileo observed these points of light moving around Jupiter. He realized that they were not stars but moons orbiting the planet. Galileo's discovery of the 4 largest moons of Jupiter, Io, Europa, Ganymede, and Callisto, revolutionized our understanding of the solar system. Galileo's observations challenged the long-held geocentric model. The discovery of Callisto and its fellow Galilean moons marked a turning point in our understanding of the cosmos and our place within it. Callisto's surface is a captivating tapestry woven with the threads of cosmic history. Its dark, ancient surface, heavily cratered and scarred, speaks volumes about the early solar system. The craters on Callisto vary greatly in size and age. By analyzing the size, distribution, and degradation of these craters, scientists can piece together a timeline of impacts. The composition of Callisto's surface also provides valuable clues about its formation and evolution. Spectroscopic analysis reveals that it is primarily composed of water ice, along with rock and various dark materials. Callisto's ancient cratered surface is a window into a time when the solar system was still young and forming. Each crater, each icy plain, each dark marking holds a piece of the puzzle, waiting to be deciphered. The discovery of Callisto by Galileo Galilei was just the beginning of our fascination with this enigmatic moon. Over the centuries, astronomers have continued to observe Callisto, using increasingly sophisticated telescopes and spacecraft to unravel its secrets. In the 1970s and 80s, NASA's Pioneer and Voyager spacecraft provided the first close-up images of Callisto. These images revealed a heavily cratered world, much darker than initially expected. The Voyager images also showed evidence of tectonic activity in the distant past, with long linear features crisscrossing the surface. In the late 1990s and early 2000s, the Galileo spacecraft conducted an extensive study of the Jovian system. The Galileo mission provided the most detailed images of Callisto to date, revealing a complex surface with a variety of features. Callisto is a giant among moons, the third largest in our solar system. Only Ganymede, its Jovian sibling, and Titan, Saturn's largest moon, surpass it in size. With a diameter of about 3,000 miles, Callisto is almost as large as the planet Mercury. Despite its size, Callisto is less dense than one might expect. Its average density is about 1.8 grams per cubic centimeter, which is significantly lower than the densities of the rocky planets like Earth and Mars. This lower density suggests that Callisto is composed of a mixture of rock and ice, with the ice component being significant. Callisto's surface is a testament to its long and violent history. It is the most heavily cratered object in our solar system. Craters of all sizes, from small pits to vast impact basins, cover its surface like a cosmic tapestry. This intense cratering tells us that Callisto has been bombarded by asteroids and comets for billions of years. Unlike some of its Jovian siblings like Europa with its smooth, icy plains, or Io with its volcanic activity, Callisto shows no signs of recent geological activity. Its surface is ancient and heavily cratered, a testament to the countless impacts it has endured since its formation. Callisto's composition and internal structure have been the subject of much scientific inquiry. Based on its density, surface features, and measurements by spacecraft, scientists believe that Callisto is composed of approximately equal parts rock and ice. This makes it a differentiated body, meaning that its interior is not homogeneous. Unlike Earth, with its distinct layers of crust, mantle, and core, Callisto's interior is thought to be more of a mixture. While there might be some degree of layering, it is not as defined as in the rocky planets. The rock and ice are likely mixed together throughout much of its interior. The possibility of a subsurface ocean on Callisto is one of the most intriguing aspects of this enigmatic moon. Scientists have long speculated about the potential for liquid water beneath Callisto's icy surface, and evidence from spacecraft missions has provided tantalizing clues. One of the most compelling pieces of evidence comes from measurements of Callisto's magnetic field. The Galileo spacecraft detected variations in Callisto's magnetic field that are best explained by the presence of a conducting layer beneath its surface. A salty ocean with dissolved ions that can conduct electricity would fit this description perfectly. Callisto, unlike Earth with its vibrant atmosphere, has a very thin, almost negligible atmosphere. We call this an exosphere. It's so thin that it's more like a slight veil than a blanket of air. This makes it vastly different from what we experience on Earth. Down here, we breathe oxygen, feel the wind, and see clouds form. On Callisto, there's no air to breathe. Sounds wouldn't travel, and a thrown baseball would sail endlessly in the weak gravity, unobstructed by air resistance. The composition of this wispy atmosphere is quite interesting. It's mostly made up of carbon dioxide, a gas we exhale on Earth. This carbon dioxide is thought to be released from the surface ice through a process called sublimation. This happens when ice turns directly into gas without becoming liquid first. The presence of carbon dioxide in Callisto's exosphere, however faint, raises questions about the Moon's internal composition and the potential for carbon-bearing molecules trapped within its icy depths. Despite its extremely thin atmosphere, Callisto is not entirely silent. It interacts with the constant stream of charged particles emanating from Jupiter's powerful magnetic field. This interaction creates a faint aurora in Callisto's exosphere. Imagine a faint ethereal glow around Callisto, like a halo, as these charged particles, mostly electrons and ions, collide with the sparse atoms in the exosphere. This glow, invisible to the naked eye, can be detected by sensitive instruments. These auroral emissions provide valuable clues about the composition and dynamics of Callisto's exosphere. By studying the colors of light emitted, scientists can identify the specific atoms and molecules present. The interaction between Jupiter's magnetic field and Callisto's exosphere also creates a very weak magnetic field around the Moon. This induced magnetic field is further evidence that Callisto likely has a salty subsurface ocean. The presence of a conducting fluid like salt water beneath the surface would explain the observed magnetic field variations. Section 3. A unique blend. Callisto stands out among Jupiter's moons. Unlike Io's volcanic fury and Europa's suspected ocean, Callisto appears ancient and undisturbed. It's a time capsule from the early solar system, offering a glimpse into intense bombardment. Callisto's surface, a canvas of craters, tells a tale of impacts, each leaving its mark. These craters, vast and ancient, others smaller and recent, paint a tumultuous past. They speak of a chaotic solar system, with asteroids and comets colliding with moons. Callisto's uniqueness goes beyond craters. It lies in its composition, a mix of rock and ice, possibly hiding an ocean. This blend of rock and ice, common among outer moons, suggests Callisto formed with rocky and icy materials. This makes Callisto fascinating to study. Its surface provides insights into early bombardment. Its potential ocean raises questions about life, and its blend offers clues about icy worlds. Section 4. A window to the past. Callisto, with its ancient cratered surface, serves as a window into the early solar system's history. Its surface has remained relatively unchanged for billions of years, preserving a record of impacts and events. By studying Callisto's craters, scientists learn about the bombardment history of the outer solar system. They infer the types and sizes of objects common in the early solar system. Callisto's surface provides clues about the early solar system's composition. The dark materials suggest that carbon and organic compounds were abundant where Callisto formed. Studying Callisto's interior could provide insights into early solar system conditions. If Callisto's ocean is rich in organic molecules, it supports the idea that life-building blocks were available. Callisto is a cosmic time capsule, holding secrets about our solar system's formation. Studying this moon helps us understand our place in the cosmos. Section 1. Destination: Callisto. As we venture further into our solar system, the icy moons of the outer planets beckon with their mysteries and scientific promise. Among them, Callisto stands out as a prime target for future exploration. Its unique characteristics make it a compelling destination for robotic missions and perhaps one day, even human exploration. Imagine a future where robotic probes descend through Callisto's thin exosphere, their instruments humming with anticipation. These probes, equipped with advanced cameras, spectrometers, and radar systems, would provide us with an unprecedented view of Callisto's surface and subsurface. One of the primary goals of future missions to Callisto would be to confirm the presence or absence of a subsurface ocean. If an ocean exists, scientists would want to study its composition, depth, and potential for harboring life. This could be achieved using ice-penetrating radar, which can map the subsurface structure of icy moons. Another key objective would be to study Callisto's geology in greater detail. By analyzing the composition of its surface and mapping its craters and other features, scientists hope to gain a better understanding of the moon's formation and evolution. This information could shed light on the processes that shaped the early solar system as a whole. Section 2. The Promise of Ice. Callisto's water ice is a valuable resource for future space missions. It can support life, shield from radiation, and fuel rockets. Imagine Callisto as a refueling station for outer solar system travel. Utilizing in situ resources is key for sustainable space exploration. One of the most tantalizing questions about Callisto is whether it harbors a subsurface ocean. While the evidence from past missions is suggestive, definitive proof remains elusive. Future missions, equipped with advanced instruments, could finally unveil the secrets hidden beneath Callisto's icy shell. Imagine a probe designed to penetrate the icy crust of Callisto, descending through kilometers of ice to reach the hidden ocean below. Such a mission, while technically challenging, would be scientifically groundbreaking. Once the probe reaches the ocean, it could begin to study its properties in detail. It could measure the ocean's salinity, temperature, and depth. It could also analyze the chemical composition of the water, searching for signs of organic molecules or other evidence of potential habitability. The discovery of a subsurface ocean on Callisto would have profound implications for our understanding of the potential for life beyond Earth. It would add another world to the growing list of icy moons in our solar system that could harbor life-friendly environments. Callisto, once a distant point of light in Galileo's telescope, now beckons us with its mysteries and scientific treasures. As we stand on the cusp of a new era of space exploration, this ancient moon offers us a unique opportunity to delve into the secrets of our solar system's past and explore the potential for life beyond Earth. The exploration of Callisto is not just about understanding this one moon. It is about unraveling the broader story of our solar system's formation and evolution. By studying Callisto, we can gain insights into the processes that shaped the icy worlds of the outer solar system. These insights could help us understand the conditions that led to the emergence of life on our own planet. Callisto beckons us to push the boundaries of human knowledge and technological innovation. It challenges us to develop new ways to explore the cosmos and to unravel the mysteries of the universe we inhabit. As we venture further into the solar system, Callisto will undoubtedly play a significant role in our ongoing quest to understand our place in the cosmos. Callisto's story is a cosmic epic, spanning billions of years. It's a story written in rock and ice, a testament to the power of time and gravity. This heavily cratered world, a silent sentinel in Jupiter's court, holds within its depths clues to the early solar system's chaotic beginnings. Each crater, each icy plain, each dark marking on its surface whispers tales of a time when planets and moons were still forming. Unlike its more active siblings, Callisto's surface has remained relatively unchanged for eons. It's a frozen record of the past, a treasure trove of information for scientists seeking to understand the solar system's tumultuous youth. The very existence of Callisto, its composition, and its position in the Jovian system provide valuable data points in our ongoing quest to decipher the cosmos. But Callisto's tale is not just about the past, it's also about the future. The possibility of a subsurface ocean hidden beneath its icy shell raises tantalizing questions about the potential for life beyond Earth. Could this ocean, if it exists, harbor life as we know it, or even life as we don't yet know it? Callisto stands as a beacon, calling for further exploration. It beckons us to develop new technologies, to push the boundaries of human ingenuity, to venture further into the cosmos in search of answers to some of humanity's oldest questions. What is our place in the universe? Are we alone? Future missions to Callisto, equipped with advanced instruments capable of peering beneath its icy surface, will undoubtedly reveal even more secrets. These missions will help us determine whether a subsurface ocean exists, and if so, whether it shows any signs of life. They will also provide a more detailed understanding of Callisto's geology, composition, and magnetic field. As we continue to explore our solar system and beyond, Callisto will undoubtedly play a crucial role. Its abundance of water ice could make it a valuable resource for future space missions, perhaps even serving as a refueling station for spacecraft venturing further into the cosmos. And who knows, maybe one day, Callisto will become a destination for human exploration, a new world for humanity to explore and understand.